Algebra. I'm the science and math tutor. Today I'm making another video for college algebra, and this is going to be my last video for the semester. I've been making like other college algebra video almost every week. I normally do like one video on a particular topic. Last week what I did was on exponential equations, how to draw exponential graphs and like some exponential functions. So today what I'm planning to do is logarithm. I just wrote some questions on the logarithm, so that's what I'm going to do for the final. Because the final is going to include chapter 6 from 6.1 to 6.6. So that's what I'm going to go over today. Most of it is about logarithms. That's what I'm going to do today. Okay, I'm just going to say you make sure that I know what time your final is going to be before like you miss it or maybe get some problems about it. Just make sure and figure out before next week, before the finals, we can know what time and date your final is going to be. Whether it's going to be in the morning, like exact day, the location and stuff. Try and figure that out. And try and make sure if you really want to, maybe you can try and study, have a study plan, maybe it's planning to study in the weekend a little earlier before the final and get like a time that you're going to review it. And I'm always at the Nasnadi. I'll be there like most of the time next week, especially on Monday. I'll be there on Monday from 12 to 7. So if your final is going to be after Monday, you can come down there if you need help. I can help you with some stuff that you need. So today what I'm going to do mostly is going to be on logarithm. That is chapter 6. Mostly is going to be chapter 6. That's what is going to be on the final. So I'm going to do questions from chapter 6, from 6.1 to 6.6. So I wrote down some questions on the paper. I'm going to go ahead and put it on the paper and just try and solve those. Okay, I got the questions right here. So I already wrote them down. I'm going to go ahead. What I wrote down. These questions, most of them, some of them are just normal questions, but most of them include the properties of logarithm that you need to know to solve most of the logarithm problems. So I'm just doing a review that, like a general stuff that will help you to solve like most of the logarithm problems. So here we're going to go first. What we're given is we're given log 4 base A is equals to 5. So what we're doing here is we're trying to write this thing in an exponent form. It's like in the form of logarithm. So the first thing I'm doing, you know, like I did exponents earlier. So what I'm going to do is how to put this in exponent form. So whenever you're given like log 4 base A, this 4 can be like any number except it can be like a negative number. It can be like all positive numbers. So that's going to be log 4 base A is equals to 5. 5 can be like any number too. So whenever I'm given that, what I do is I take the base and make this 5 the power of the base and equate it to that. So that is going to be A to the 5 is equals to 4. Now I'll put it in exponent form. This A to the power 4 is in the form of exponent, not logarithm. So A to the power 5 is equals to 4. That is the way to write it. Okay, the second one is 2. 2, when I get log x base 5 is equals to y. It's the same thing I did here. This thing can be anything. So just put that on that, which is going to be 5 to the y is equals to x. So that's going to be like any case. It doesn't matter what you get here or what you get here. Whatever you get there, just put that the power for that and equate it to that. So it can be numbers, it can be like anything. It can be numbers, it can be variables, it can be anything. So here the fourth one, what I get here is log 16 base 2. I get log 16 base 2. So here, okay, I'll go number 3 first before number 4. Okay, number 3 is e to the b is equals to 9. You know here, I get the logarithm, I was changing it to the exponents. Now here, what I'm doing here is changing this exponents to the logarithm. That's what I'm doing here, changing the exponents to the logarithm. Okay, so here I'm changing the exponents to the logarithm. What I'm going to do, I'm going to take the logarithm of both sides. So here I get e here. So if I want to eliminate this e, I'll just take like a log with base e. So here what I'm going to do, I'm going to take log base e on each side, which is going to be e to the b is equals to log base e. 9. So if I get that log to any number base to that number is equals to 1. And if you get any number to the power, you can bring it down here. So this is going to be b log e to the e is equals to log e to the 9. So log e to the e is equals to 1. Log e to log any number to that number base number is equals to 1. So this is the same as b is equals to log e to the 9. Okay, that is the third question. So this is changing the exponent to the logarithm. This is logarithm to the exponent. Now I'm going to do like the questions to solve it, just putting the numbers in to solve it. So here what we're going to do, we get log 16 base 2. So to solve this thing, what I'm first trying to do is to make this thing here 2 so that I can get a 1, like log e base e is equals to 1. That's what I'm going to do here. So my goal is to make this, to turn this 16 to a 2. So to turn this 16 to a 2 is going to be log 2 to the 4 is the same as 16. So I can substitute this 2 to the 4 by this 16. I'm trying to change this base to 2 so I can get 2 up 2. So here what I can do, I can put the 4 here. So it's going to be 4 log 2 base 2, which is 1. So this answer is going to be 4 times 1, which is 1. So I get another one here. 5 2 is like the same thing. I get base 3. So my goal is to put this base, turn this base to 3. So it's going to be log 1 over 27, same as 3 to the 4. Yeah, no, it's 3 to the 2. 3 to the 3 is 27, not 3 to the 4. 3 to the 4 is more than 27. So it's 3 times 3 times 3 is 27, base 3. So if I get that, I'm trying to put this thing on top. This is going to be log 3 to the negative 3. Because I get this 3 down here. If I put it up, it's going to be to the negative 3. Base 3. So if I get that base, that is equals to 1. But I can put that one up here. So if I put it, it's going to be negative log 3 base 3. Log 3 base 3 is 1. So it's going to be negative 3 times 1, which is negative 3 is going to be the answer. So number 6 is, those are one of the properties, like the logarithm of 1 base a can be like, okay, the logarithm of 1 to any base is equals to 0. So that is something that you're supposed to know, is equals to 0. Anytime you get log 1 is 0, no matter what the base is. Either the base is 30, is 40, is 50, this thing is 0. As far as it is log 1 is 0. So that is number 6. Number 7, I get a, that is a log m base, this one, a log a base m is equals to m. Whenever you get a logarithm, this one, whenever you get, this is kind of like an exponent with a logarithm together. This is a to the 3 power something, which is an exponent. So whenever you get a, the base here, a, and that here is the same. Like if you get 5 here and 5, the answer is going to be whatever number is up here. Like if you get 10 here and 10, the answer is going to be what? As far as these two are the same, if they're equal, like the same, the answer is going to be the logarithm, like the number up here. That's why this thing is equals to m. That's another property that you should try to remember too. So that is number 7. Number 8 is like a to the r. That is what I was using, putting this thing back here. Whenever you get log a to the something, you try and put whatever is on here back here. So this is going to be equals to r log a base a. So log a base a is equals to r, because log a base a is 1. So it's going to be r times 1 is going to be r. So whenever the base and the log of which, like the number you're taking and the base are equal, the answer is going to be the exponent of the number here. So that's what this property is saying. So there's another one. 9 is log a into mn. So whenever you get multiplication, a log and two numbers that are multiplied, or maybe two variables that are multiplied, the way you expand it is going to be log a m plus log n base a. So whenever you get multiplication between two variables, you expand it, put in addition between them, and you take logarithm a, logarithm b of that. That's how you do that. So if you want, you can take it back to, if you take it back, it's going to be log base of, if like they are common base, m times n. So whenever you get divided, that one, when you expand it, you put minus there instead of plus. So this is going to be log base A m minus log base n A. So whenever it's division, you change it to minus. Whenever it's multiplication, you change it to addition when you expand it. So this one, you can take it back to, whenever you take it back to, it's going to be division. So you can take it from here to here or from here to here. Or you can take it from here to here or here to here. So they can go like either way. So the next one I'm doing is log A m to the r. So whenever you get log a m to the r, it's the same as when you bring like the r up here. It's going to be r log m base a. So these two are the same. I've been doing that like since I was solving those questions. Whenever you get the power here, you bring it on this side. So the other one I get is a to the r. A to the r is the same as e r natural log of a. Natural log means like a logarithm with, like if you get log base e, is going to be a natural log. A logarithm with base e is called a natural log. So a to the r is equals to e to the r natural log of a. So a can be like any number and r can be like, r is like the exponent, r can be anything. So I did like some of these properties. So I get some at the back too. I get like a question to solve on. So I get some at the back here, and I get another question here that I'm going to solve. So whenever you get log m log m base a, you can write it out as log m over log a, provided that the base have to be the same. For example, if the base here is b, the base have to be b here. Or if the base is 10 here, the base has to be 10 here. If the base is 15 here, the base has to be 15 here. It doesn't matter what base you put there, as far as the base you put here is the same. So anytime you get a logarithm, you can expand it this way. Like if I give someone log 5 base 6, it's the same as log 5 over log 6. So if I put the base here 10, this one has to be 10. If I put 5 here, it has to be 5. So any logarithm you see, for example, if I say log 5 without any base, you assume that it is base 10. Any logarithm you see without a base, you assume it is base 10. So what I'm going to do, this is what the 14th one I get here. I'm going to solve like a question that is involving logarithm. So it involves one of the properties I was talking about on the back page, on the first page. So here, what I said is, when you get log m n, thus you get multiplication between them, you can expand it as log m a plus log n n, and if you get division, you can do that. So here what we get is, we get addition here. You see how here I said you can take that back from that. So what we're going to do, what we get is, we get two logs that are the same base and it's addition between them. So it means we can put multiplication between whatever we get on here. So it's going to be log base 5, we maintain the base and we multiply those two. So that's going to be x plus 6 times x plus 2. I don't know if I write the question right, but I get x plus 2 here and x plus 6 is equals to 1. So I'm going to use that to solve this equation. So this is going to be this times that is going to be x squared plus 6 times plus x times 2 is 2x plus 6 times x, 6x plus 6 times 4. 6 times 2, which is 12, is equals to 1. This is log 5. Sorry, this is log base 5 of that. So if I get that, this is the same as I said, if you get a number, if you're going to change it to exponent, you just take the power to that and you equate it to that. So this is going to be 5 is equals to x squared. 2x plus 6x is 8x plus 12. So if I put the 5 here, this is going to be 0 is equals to x squared plus 8x plus 5 minus, if I put this 5 here, it's going to be minus. So 12 minus 5 is, 12 minus 5, I think that's 7, right? 12 minus 5, that is 7. So I get like a quadratic equation. So you can, if you solve, you can like, after that, I'll go ahead and solve the quadratic equation. This is 7. So you find two numbers that when you multiply them, you get 7. And when you add them, you get 8. So if I multiply 1 times 7, I'll get 7. If I add 1 plus 7, I'll get 8. So here I'm going to substitute this, add 8x with 1 and 7. So it's going to be 0 is equals to x squared plus 7x plus 1x plus 7. So I'll just put the equals to 0 on this side because that's what people are used to. So here I will say x into x plus 7 plus, this is going to be x plus 7. That is 1 into x plus 7, so 7 plus 7. So if this thing is the same as x plus 1 into x plus 7 is equals to 0. So x is equals to -1 and x is equals to -7. So that is the solution for that. But the main thing I did this is so like how I did use some of the properties of the logarithm I was talking about. If you get addition, you multiply the 2 and maintain 1 log. If you get division, you subtract the 2 and maintain 1 log. Sorry, if you get minus, you divide the 2 and maintain 1 log. But here's plus, so we multiply the 2 and maintain 1 log. So we finally get that. Okay, these are some of the properties I talked about. So these are some of the main properties that will help you to solve most of the logarithm questions. Okay, I'm gonna start there, and if you get any problem on that college algebra or what I'm explaining or anything that you think is gonna come on to the final, just come to the Monday from 12 p.m. to 7 p.m. If the test is going to be like on Monday, you can come. I will be there at that time. I can help you, right, if you need help on any of the problems. Okay, this is going to be my last college algebra video for this semester. Sorry, finals.